All right, so I'll start the recording and make the introduction. So as I said before, I'm covering for Anna today, who unfortunately couldn't make it. So we're very happy to view a talk or listen to a talk by Professor Guilherme Maia de Oliveira Wood, who is a psychologist and neuropsychologist at the University of Graz in Austria. He had graduated in psychology from the Federal University of Minas Gerais in Brazil and obtained his PhD, I'm better pronouncing this one, at the Rheinisch-Westfälische Technische Hochschule in Aachen in Germany. And now he lives in Austria since 2005, working first at the University of Salzburg and since 2011 at the University of Graz. And his main interests are in the development and validation of instruments for neuropsychological rehabilitation, which are able to introduce direct neuroplasticity in brain-damaged patients. And his approach is seen as hierarchically organized. In his approach, he sees psychological rehabilitation as hierarchically organized and as a complex biohybrid system. And in recent years, his main focus has been on different types of brain-computer interfaces, digital technologies, virtual reality, and so on in rehabilitation programs. And he's also engaged in improving the quality of psychological research with the aim to overcome the replication crisis. It's very important, and to promote fair and rigorous scientific communication, as well as guaranteeing an ethical and responsible use of neurotechnologies. And today we'll hear about safeguarding mental privacy in neuroscience and the associated societal, legal, and ethical challenges. So thank you very much, everyone, for coming. And Guilherme, you have the stage.
Yes, thank you, Sebastian, for your kind introduction. Hi, Rab. Nice to see you again. So perhaps I start by sharing my slides. So that's the opposite combination. Right, can you confirm that you are reading my first slide?
Yes.
Yes, great. So yes, you already know the title of my presentation. And in the introduction of my person, so you already heard shortly about so the purpose of our department here in Graz. So we are neuropsychologists. So most people working here are psychologists by training. We develop, validate technologies mainly with the aim of employing that in neuropsychological rehabilitation, so in some rehabilitation strategy, which often enough involves reorganization of neuronal networks, induction of plasticity. Yes, we have to take care so to clinically test the effectiveness of the procedures we are using. So we work quite a lot with neurofeedback and also combine that with different other technologies. So Sebastian mentioned our work with virtual reality. So this is also a big part of our mission here. And because it's also a topic, we also pursue a line of research on psychosocial influences on treatment, mainly because neurofeedback is under so strong psychosocial influence. Yes, I don't have to explain to you much about neurofeedback. So you are experts in brain-computer interfaces. So here you're seeing so some of the situations of training of rehabilitation as we have them. So some are home-based, other lab-based. Yes, so I don't have to extend myself. Yeah, today I'm talking specifically on a much broader topic, so it is not really BCI research. It's more about setting the frame socially and culturally. So to think of the new developments of BCI and specifically of neurofeedback, because so this is the technique we use the most, but it applies and should be valid for every other neurotechnology as well. So Sebastian mentioned our perspective on so the interaction between people and technologies as so biohybrid systems. So because so the technologies can talk to each other so much, and so um, the ease with which we can combine them and create new technology, so by just integrating two existing ones, and also so the interactions with the users and all the mechanisms we are targeting when letting people interact with these technologies. Yeah, so this is a big topic, and today we will discuss the so what would be desirable so to take out from the neurotechnologies the very best and avoid uh, so the problems. So then so yes, another point. What I'm presenting here today is mainly part of a study we wrote for the European Parliament. We finished that last year. So it's apparently a very urgent demand, not only from the European Union, but worldwide. So to think about regulations and so the anticipate the risks and benefits of the neurotechnologies. So there are several developments right now, and this is also be part of the presentation. Yes, so this is the team of the PIs working on this study for the scientific and technological observatory of the European Union. So I'm the guy in charge of neuropsychology, and my colleague, I need a laser pointer. Yes, Juliana Jake is our sociologist. Thomas Gremsel is our specialist in ethics, particularly social ethics, and Elisabeth Staudiger, our specialist in law. Yes. So this is the team again. I already named the professors, and so these are the PhD students who collaborated and did the hard work for this study. So which were our tasks? What did the European Parliament want to know? So they wanted to understand legal, ethical, and societal implications related to neuro enhancement, technology development. So as Neuralink is putting that forward, assess the need for adoption of new legal and regulatory framework at EU level, as proposed, for example, by the Neurorights Foundation. We will come back to the Neurorights Foundation later in my presentation. So this is a think tank, an American think tank, very engaged into putting forward some very specific ideas on regulatory framework for neurotechnologies. And so what their proposal was the main target of our study. And we also, of course, addressed the interaction between neurotechnologies and other artificial intelligence from the point of view of legislation. So the European Artificial Intelligence Act was promoted a few months ago, so was published and is a law since then. And yeah, so we also were in charge of envisioning some policy options for the European Union, so to guide the next steps in the direction of a discussion on neuro rights. So whatever this should then be. So yes, complementary reading and watching materials, so to the presentation I'm giving to you today, can be found under these links. So you have the presentation, then you should be able to read our study and also watch the presentation at the Parliament in Strasbourg, as well as some other grant proposals we are working right now. One of them is called Memory AI, Styria. So it's about the use of neurotechnologies in the rehabilitation and care of dementia patients. And there are also workshops connected to this project, so you can follow that as well. So there is a website, and these materials are online. The other ones are for people who speak German. So you can contact me again if you want to have these sources as well. Right. So we'll then start the presentation defining what we understand under neurotechnologies. So there are several different definitions. Um, um, and so they fulfill different goals. These definitions of neurotechnologies, let's pick one of them, so to work, and we did that for our study as well. And then I will present to you so the four disciplinary perspectives from psychology, sociology, ethics, and the legal perspective on the proposals by the Neurorights Foundation and what it has to do with neurotechnologies. Yes, so these Neurorights, I'll come to that later, and we'll finish so with some provisory conclusions. Yeah, so neurotechnologies are methods to record, interpret, manipulate brain activation. So it's a very broad scope of techniques. They can also be combined. They can measure brain activity, or we can infer brain activity also from other techniques measuring behavior as well. So depending on the definition you are using, you would extend so neurotechnologies also to other techniques which are just measuring behavior or correlates of brain activation and can help you infer specific brain states. Yes, very important here is to note that specific neurotechnologies have very different degrees of invasiveness. So so also a quite important topic in the BCI research. So how invasive and how precise can a specific BCI application be. So the more invasive you are, usually you gain in precision, but there are also other consequences of that. So the risks involved and the commitment of the patients so to the use of a specific technology is much higher than in the case of less invasive technologies. We have a spectrum of technologies from not invasive at all and requiring absolutely no commitment up to very, very invasive technologies as well. So this is nothing new for you. Yes, and so the neurotechnologies are also used for very different purposes, and this is also an important factor to consider. So we have several neurotechnologies being applied for rehabilitation or for medical treatments, so to enhance people's autonomy in daily life, because so they have a health problem or a disability, and you want to use the neurotechnology to correct that, or to improve people's life, increase quality of life, or increase functionality, and so on. So this is a more health related context. Beyond that, you also have perfectly healthy people interested in neurotechnologies for the purpose of enhancement. So for some private reasons, or even in the case of specific military applications, because of institutional organizational demands, so you will engage in so the use of enhancement by neurotechnologies. So these can be stimulation devices, or devices which will increase or expand your abilities as a human, so to solve specific tasks. So it will optimize your performance. So in many cases, it will involve inducing neuronal plasticity. Definitely, it's connected with a learning process in several applications, and other ones, so they just shift your brain activation mode to a specific different level. It would be pretty hard or impossible for you so to achieve without the neurotechnology. So this is the neurotechnology for enhancement. There's a lot of curiosity and expectations of advantages individually connected to the neuro enhancement technologies. And here as well, so you see a spectrum of invasiveness from not invasive at all, so to very invasive technologies. And we also have the use of technologies for entertainment. So as an accompaniment for games or other entertainment activities. So you also have applications of neurotechnology, so to interact with other forms of entertainment, so in a dynamic way, so to increase engagement, increase interest, and so improve the experience of entertainment. So while in the case of rehabilitation, we are talking about health issues. In the case of enhancement and entertainment, it's definitely not the case. So the motivations of people to approach neurotechnologies can differ quite substantially. And beyond that, yes, in many cases, so the same neurotechnology, almost without any change, can be applied in these different contexts. And this will be later on one of the challenges for the regulation of these technologies. But let's progress step by step. Yes, in this spectrum of invasiveness, you can identify specific technologies and classify them depending also on some other properties they may have. So one axis of properties is so the degree of invasiveness of specific technologies. So usually if you have a highly invasive technology, so the validity of the application, so your ability to measure and interfere with neuroactivity in a very specific way is given. So the reliability also uses to be quite high, because so you are addressing a specific neuronal substrate quite directly. And the more invasive usually, so the more you are sure that you are targeting a specific group of neurons and in a specific way. So you have very good evidence usually from animal models and also on human models. So you understand the the substrate of the neuroactivity you are measuring quite well, because so you can go very deep in a high level of detail, and you also have a high level of precision if you do that well, and high level of control for physicians. On the other side, so with decreasing degrees of invasiveness, so you have other properties, as so the usability is much easier. So you can just wear a cap, and so it has no further implications for your life, no risks. So they may have a low durability, um, um, but also other ones can have a long durability, because so your commitment is not very high. So you can decide at any time so to stop the use of the technology, and can you plug in again. You also will observe that so some of these technologies have a direct-to-consumer service, so you can buy this technology as a private person and use them. So at least in the US, you can buy some neuromodulatory technologies, and so brain-computer interfaces for interaction can be used, can be bought anyway without any medical prescription, of course not. Yes, if it is malfunctioning or not working at all, it has barely any negative consequence for the person, except for the frustration of the spent money. And they are comparable in comparison to invasive technology, so rather cheap options. Yes. So these are desirable properties of these technologies, and you see, so the higher the degrees of invasiveness, so more you will go in the direction of this kind of property in the right upper quadrant. And if the invasiveness is lower, so you go to the lower right quadrant. And on the left side, so you have less desirable properties of the same technologies. So in the case of high invasiveness, so the risks are much higher. So the level of commitment, so once you started using the technology, so you are more or less forced to keep with your choice. May also have laborious calibration unities. So before the technologies are working, and if they malfunction, so the consequences may be quite severe. In the case of less invasive technologies, you see that you have less validity, so you have no clue on what people are actually doing when interacting with the technology. So it can be for many different reasons that, so you see some response. Lack of reliability, so they are much less stable, because the degree of commitment is also much lower. So the conditions in which you use the technologies are definitely much more variable. So people trying them out at home, so we'll of course not usually do that in a very proper way. You also see that many of these technologies are available without any scientific validation, so by means of well-controlled randomized trials, things like that. So the precision, so if you think of EEG, so EEG is measuring not only EEG, but also many artifacts. And so separating the real brain activity from other forms of electrical potentials can be quite a challenge. Yes. So this table will be important later on for several reasons. So when we think of the spontaneous beliefs of people interested in neurotechnologies, so they can be quite naive, and they will mix up properties of the different quadrants in this table, and we'll see the consequences of that in a moment. Right. So in our study, what could we conclude? So in the way the Neurorights Foundation presents its proposal on what is needed for humanity regarding new laws and rights towards so the use of neurotechnology, we see that their language produces a conflation between brain and mind. So quite often when they are talking about the brain, they are actually describing cognitive functions. And so this ambiguity regarding neurotechnology, so it has been promoted at least in this think tank, so it's quite clear. And the reasons, yeah, so you may ask why, so to keep the discussion so blurred. So this has some consequences we will address in a moment. Yes, we also see in the case of most neurotechnologies, so we need much more research, so to be sure of the implications of their use, not only so the desired positive effects, but also all the side effects and possible complications. And beyond that, so all the commitment implications as well. So what to do if the device fails? So who is responsible and who is acquaintable in case of misfunctions? Yes, we also observe that in the public discourse on neurotechnologies, so a transfer of reputation from high invasive technologies to low invasive technologies and the other way around are very common. And usually the focus is on the desired properties of these technologies. And of course, so if you have you expect a high degree of precision combined with a very low degree of commitment. So these technologies are not available. Usually you have to um, um, increase the level of commitment and invasiveness, so to get the higher levels of precision and stability. Yes, when you look at what commercial manufacturers of the different devices proclaim regarding so the possibilities and limitations of their products. So they are quite frequently not very scientifically underpinned. So there will be a quite hyperbolic tone in this context. And this, of course, is feeding so the already very inflated expectations of lay people towards neurotechnologies. So you expect that everything what is being told to you is true, and everything you may listen about neurotechnologies is possible anyway. And of course, it's not. So this phenomenon has been called in the literature neuroenchantment. So just in case you are not familiar with this concept, so the neuroenchantment is quite common in public debate. So you'll see a slide giving examples of that quite soon. And yes, so to counter the effects of neuroenchantment, because it's biasing the public debate on neurotechnologies, so it's pushing the public perception only to the positive side of the technologies. When we consider how fast Neuralink is getting ethical approvals and implanting people with their system, so to fulfill several tasks in daily life. So we should consider that it has negative implications as well. And it's pretty hard to keep people focused on at least this possibility, so that neurotechnologies may have some side effects or may not be as desirable as people think that they are. So the so-called new enchantment. So here are some rather harmless examples of neuro enchantment in daily life. So you see that every product you combine with the prefix neuro can be sold much more at a much higher price than its equivalent without the neuro prefix. So you see there are neuro socks. What is special about them? So they have a sole where so it will exert some extra pressure on specific parts of your foot, and this is it. So so this differential stimulation, of course, it will be transmitted to the sensorial cortex, and it will influence your uh, central nervous system. But yeah, so in a very predictable way. So the socks can be quite expensive. So I have seen some models for €70 a pair. And so their function in comparison to other orthopedic socks is not superior at all. Yes, you also see that in shoes, so neuro shoes, which promise you something similar. Also, so a bubble gum, so to stimulate your central nervous system, so give you energy and keep you focused. So there are some very unspecific effects of chewing gum on precisely these functions. This has been known for many years. If you look at PubMed, some studies, so there will be perhaps over 100 studies on precisely that. So it wasn't invented by these guys from Neurogum, but probably so the Neurogum cost us much more than ordinary bubble gum, although yeah, so the effect is probably precisely the same. Also energy drinks, so making you a lot of promises, and also more sophisticated examples, so like products containing neurotransmitters. The thing people usually don't know is that so the GABA you may buy and eat as a food supplement, so it will be broken in your digestive system. So none of it will be carried so to the central nervous system, so to fulfill its inhibitory function. So this kind of mock, but it's very popular, and so it's not forbidden by law so to sell products like this. And so this is perhaps one of the problems we have with other neurotechnologies, because so these half scientific truths sold so to lay people, so they are easily believed, and so this lays at the core of neuroenchantment. You also see that lay people understand that and expect that neurotechnologies will bring them good things. And so a whole culture of do it yourself neurostimulation is already available. So you can buy TDCS equipment, so to try that at home. If you look in YouTube, so you can also build your own apparatus. So this is something people interested in neuro enhancement we pursue quite often. Also have international conferences on biohacking, and so this has been quite popularized So it's of course part of this culture in which the most central aspect of you as a person is your brain, and so your physical brain, and doing your best to optimize the brain activation is of course in this specific cultural context almost a moral obligation. So people see that as an important thing to do, and will be willing to buy and use neurotechnologies even in an unsupervised way to do that. Yes, with all the consequences. So you can get some burns from these machines, or you can also pass some electrical current through your brain in an undesired way. So, or in excessive doses. So these are things, of course, to consider, but which usually will only be available in the minds of the experts and not of the lay people. Yes, but what is the scientific evidence for the existence of neuroenchantment? There's a very funny, simple study published 2014 demonstrating how the connection between devices promising to give you some more specific information on your brain activity, so they have a very high credibility. And so these authors invented a name for a fake device and used a big hair dryer to mock a brain reading machine. And so the experimenter was actually having a close look at the pupils of people, and so the reflections on the surface of their eyes, because so he could see what they were watching on their screen, even if he was behind the screen. And with a high probability, so these guys could guess the images the participants were seeing, and they were told, so my machine, so my spintronics is telling me that you are looking at a square or a triangle right now. And people were quite impressed. And so participants in this study were college students, some of them with a background in neuroscience, so people who should know better how these things work, and other students without a particular training in neuroscience. And you see that 73% of the students there, when asked at the end of the study whether the machine was, they believed that the machine was really able to read their thoughts. So they said, yes, yes, of course. And among the students with a neuroscience background, the number was 65%, so it's still quite high. So this means we all are probably under this kind of enchantment. So we are driving our perception in the direction of acceptance and willingness to believe anything connected with the activity of these machines, even if everything is explicitly fake. And in the case of this study, so the authors on purpose did not care too much to make the machine very fancy, and still they could catch people's beliefs quite easily. Yes. Another fact I always observe in our studies, which are placebo controlled, is that most people believe to be in the experimental group. And so here are the percentages in two of our studies. So people from the experimental group, so 75 also believed to be in the experimental group, but in people from the control group, so all of them believed to be in the experimental group as well. In another study, so half of people in the experimental group also reported, I think I'm in the experimental group. but so the people in the control group with ineffective feedback, so in their majority believed actually to be in the experimental group. So this effects of a expectation, so that the technologies are actually accessing your brain activity. So it's quite powerful. It can be suggested, easily suggested, as in the neuroenchantment study, and it's also part of every other, even the real applications of neurotechnology. So people have very strong expectations on that. We ran a study on how people talk on Twitter about neurofeedback, and we saw that so the topics behind people's conversation on Twitter, so they are quite compatible with the strong presence of a neuroenchantment. So this is the traffic connected to the keyword neurofeedback on Twitter. You see, so there are some peaks of activation there. So these were critical studies which were mentioned in the literature. So actually criticizing the poor state of evidence in neurofeedback research. And then you see that shortly after these peaks of activation, you see two other ones. So one of them is a peak of the discussion based on the keywords evidence or evidence-based. And we looked at these particular tweets. And what we found was old evidence, which was part of the criticism put forward in these studies by Robert Thibault. And so you see this conversation in Twitter, it appropriated the specific concept of evidence-based research or evidence-based therapeutic use of neuroenchantment, but connected with a bunch of bad studies on neurofeedback. So actually, people didn't learn anything from these critical studies. So arguing for stronger evidence. So people were still citing the old poor evidence, but using the new vocabulary to readdress that. So they didn't realize that actually there was a contradiction there. Right. I don't want to extend too much on that. So yes, here we see invasive technologies, and so here is one example of a bionic eye. So a few hundred people got in the US, and then the company went declared bankruptcy, and so there is no support for people, so no insurance is responsible for that. So when you have more invasive technologies, you should have a much stronger legal basis so to protect the users. And this in many cases is not happening, just because so the development of this technology is so fast and the enthusiasm is so high that people ignore that in many cases you may require some more protection. So here is what I mentioned before, so this transfer of reputation. So even in the case of the use of highly invasive technologies, many cases people will still use mental framework which is originated from much less invasive technology. So people will underestimate the risks behind invasive technologies, and will also overestimate the ability of technologies with a low invasiveness, so actually to produce precise results. precise and so strong results. Right. So what were our findings? So from the sociological perspective, so in our modern culture and modern societies, so where we have a big enthusiasm towards new technologies, so neurotechnologies are not really an exception. Actually, just the contrary. So we have very high expectations towards neurotechnologies, and they can go too far because so these expectations in public discourse are not necessarily guided by strong scientific evidence. So they are more guided by other sources of information, which can be not only biased but plainly wrong. Because of advertisements and also the strong expectations of people. Yes, and when new neurotechnologies get more popular and become part of usual social interactions, you may see that so they will redefine social problems, will create new norms on what is acceptable, what is expected from people to do. In some cases, so there are some examples in this book here, so Instrumental Intimacy, where this author, so this is Melissa Littlefield, cultural anthropologist from the US, who wrote a very interesting book on EEG wearables and expectations towards neuroscientific devices. Yeah, some of it is interesting and welcome, but other parts of it are definitely not. And so she underscores how some institutional or organizational demands for neurotechnologies may reshape our right to privacy, our rights to have a mental life beyond what is necessary for our productive activities. And so neurotechnologies allow that, so that other people can watch, measure, predict what is going on, or read out what is going on in our private minds. And so this is definitely something we have to be aware of in all their implications. Yes, and also, so this anticipation, so these strong expectations towards neurotechnologies which probably do not exist yet, at least not able so to deliver what all the promises have been done by their creators. So they already generate an impact on present actions of people, and so the way people interpret their level of choice regarding neurotechnologies. So is that still an option, or is that something everybody will be using soon, and then I have no choice and I will adhere to that as well? So in the case of more invasive technologies or technologies which have a component of are going deep into our private sphere. So this is definitely a thing we have to consider. Well, the Neurorights Foundation already thought a lot about that. And so their first idea was that this right to mental privacy, and so the right to protect your personality against changes and manipulations, as well so a protection of your free will and decision-making ability, so your individual autonomy, and also so our collective autonomy as a society, as well as so fair access to mental augmentation. So you should make it available for rich and poor people, as equally as you can, as well as so protection against biases in algorithms used by neurotechnologies. So all of it should be addressed in the form of new human rights. And so at first, it may seem to be a very good move, um, and a good idea. And so they also produced a lot of literature, which you can also see on their webpage on that. And we considered whether these new rights, as formulated here, should have a place at the level of human rights or not. I can anticipate to you our conclusions. So definitely not at this highest level of legislation, so human rights, because the human rights protect the human person and not only the human brain. And it's much more advantageous to protect the whole person, including the brain, and not doubling rights people already have. So actually, what we are in need of is more concrete legislation at lower levels, because there is where concrete problems show up. So it's quite hard to make cases about violations of human rights. So you have to go very, very far to convince any court about violations of human rights. But consumer rights, so this is a thing of daily life. And actually, so it's much more useful for to increase protection against surveillance, against invasion of individual privacy, and to protect people's autonomy and ability to think and decide if you focus on this secondary law. So this is how it's called. So here you see a few more publications by the Neurorights Foundation. Yes, so from the ethical perspective, so we should be quite aware of the risk of diluting or inflating the human rights with new rights for the brain. So neuro rights at the level of human rights seems to us to be a very bad idea. The neurotechnologies and their use, so it should bridge the gaps between humans. So it should definitely promote solidarity and should promote the human person as an individual and as a collective, and should also be in promoting a better life for everybody, and not produce bigger inequalities, or enlarging the gaps between different groups of people. Yes, so a fair distribution, protection of the individual, and equal opportunities of use of new technology in an informed way, so are quite essential. So to achieve that, we have to understand the mechanisms of neuroenchantment quite precisely, so to be able to have fair discussions on the possibilities of use of neurotechnologies. Yeah, so the EU is authorized. Yes, thanks for remember me. I will be ready in a minute.
All right.
Thanks. The EU can take action, so to think of new norms and regulations, because of the so-called precautionary principle. So in sight of the threat of by the misuse of neurotechnologies in the future, so to prevent that, so the European Union can at any moment start discussions on complementary regulations. And so the EU Charter of Fundamental Rights is already quite useful. So it's comprehensive, and it's proven to offer people enough legal protection. And so the adjustments we need So they should be situated at the level of secondary law. So the standardization of devices, and also so the considerations on what is a safe use of a device. So beyond the more technical, physical aspects of each device. So you should also consider the level of manipulation you can perform in name of this device. Yes, so, right. The recommendations, so a risk evaluation to complement the AI Act is a good idea. Public communication and promotion of a fair communication on limitations, risks, and hypes observed in neurotechnology, as well as so the building of neurotechnology literacy seems to us also to be a good idea, and focus more on what can be done at the level of secondary law also seems to us to be a good idea. Funding more research, taking care that there will be an European space data, so to protect data of digital data of European citizens, and also the question of standardization. So also to consider all social and ethical aspects beyond so the physical usability of devices in the process of standardization. So there is already enough normative effort put into that. So we should consider that anyway. Right. So the conclusions, I already mentioned most of it. So I may emphasize that we should take more care of neuromyths and the existence of neuroenchantment. So to have a fair public debate on what to do and what not to do with neurotechnologies, have a risk-based approach, as in the case of the AI Act. Yes. So by guaranteeing that, so we will have the best of the neurotechnologies and prevent misuses also the best. Yes, with that, I thank you very much for your attention. So I already 4 minutes over my time, and I, of course, available for questions. Thank you.
Great. Thank you very much, Guilherme, for this interesting perspective. Are there any questions from the attendees? There was one comment in the chat about a similar program taking place in America.
Yes.
Yeah. I haven't looked at it. Do you know of
yes,
it?
I can tell you that because I am also involved in the discussion from the Austrian perspective on a new document, so a set of recommendations by the UNESCO about so the use of neurotechnologies, and so this discussion is everywhere. So in the US, you have. Of course, because so they are driving most of the new developments on the very invasive neurotechnologies. So a discussion is definitely necessary, and so more public participation in this development. So political influence on what is going on is very desirable at this time point. You also have new developments in China, and so the promise so of something amazing coming out soon. So they are also investing considerable effort into improving neurotechnologies. Some people with a stronger focus on the very invasive technologies, other ones preferring so the less invasive ones. Yes, so in Europe, yeah, you have the same developments. And other countries in the world also have some attitudes towards neurotechnologies and neurorights. So you see in Chile, so there was some movement so to incorporate more legislation in their Charter of Rights. But at the end, it backfired, and so only the very general principles were incorporated, and so the more concrete law, which, by the way, was a bit problematic, so it was not approved. So this was a gain, yes.
Right.
And so people from all nations in the United Nations are contributing for this new document by the UNESCO. So it will be published later this year. So if you don't have access to these documents, so there are a few presentations on that. I can point you to that. So if there is interest, yes.
Sure. Yeah.
There's a big movement right now. So to chart the rights, possibilities, and rules of conduct for research. Yeah.
So if you could distill your observations based on this research down to one recommendation for, say, PhD students on how to be responsible in their research, what would you tell them?
So one recommendation, yeah, this is pretty hard. So my first recommendation would be, so to focus on sound evidence and not be fooled by your own enthusiasm for so the technologies. It's pretty hard to separate things. Yes, this is one point. Adhering to so best possible data quality. So this is of course valid for every field in science. But in these fields of science, getting a lot of attention, public expectations as neurotechnologies, it's harder. So because everybody also expects from you specific answers and a specific optimism. Yes, so you should take care not to exaggerate.
Yes.
And so to contribute, so to explain the possibilities and limitations of each technology, it's a good thing.
Yeah, sounds wise. All right, thank you very much again. I also have to go to another meeting. Are there any remaining questions from the attendees? All right. Then, Ido, right.
Thank you, Sebastian, for the last question you mentioned, because I also thought in that perspective what we can take from this, because some things seems to be exaggerative. But thank you, the presenter, for a very nice perspective about this. My question is on neuroenchantment.
Yes.
From all of these, what would you say is the reason for this? Is it that the physical perception of the maybe human beings, or would you say that our brain maybe fires in certain ways when certain things are or contents are presented? Yeah.
I'm not sure I understood your question. So it's about neuroenchantment.
Yeah.
And so are you asking me what is happening in our brain when we are under neuroenchantment? Is that the question?
I'm asking the resultant for that, if you get it correctly.
Well, so the neuroenchantment is a state quite close to all other forms of illusion. So when you prepare an audience and make tricks, so it's pretty convincing. And this is because so you are playing with people's attention and expectations, and because so they are away from what is really going on. So you can convince people of amazing things. Well, it happens because we have these expectations that so the reading out brain signals will reveal something very deep about ourselves on a private level, what is usually not really the case. So we can categorize some mental states, but we are still far away from so easily decoding every deep thought we may have. So they're right. So it's not yet feasible. But the expectation of people is that so you can go very deep in their mental activity, and yeah, so this generates so this set of expectations, and because the device seems to corroborate the expectations, so you believe it, and so inoculate people with some more useful thoughts would break the neuro enchantment. But if you let people unattended and you approach them unprepared, it's quite probable that they'll go for it. As in the case of any other so important promise, so if I would tell you a way so to get rich quite easily, so this a very nice thing, right? And if it would cost you almost nothing to go there, you would give it a try. So you would believe that probably, or not, because you are an intelligent person. But most of us fall for this kind of trick from time to time in different contexts where we are not prepared so to think critically.
Oh, thank you very much.
You're welcome.
Thank you very much.
Hi, Professor. Thank you so much for the presentation. And it was really good to see you again after a long time. Well, I don't have really a question, but I was just like thinking of out of curiosity that how the exploitation of nanotechnology, neuro world has been used in the industry. And you just mentioned about the neuro socks that you already bought. So what was your expectation, and how did they meet you or not? So what was your perspective on that?
My expectations towards neurosocks, so I know it's a scam.
Yeah.
But yes,
But have you tried
so what is behind that? So you want to do something good for your health, and so more expensive products, because so if you frame the socks as something connected to the brain, so then it's connected to some very smart research on so ways to influence your brain. And because so none of this is true, but people expected it anyway. So then you can play this game where people, because so they want to have these high gains without a lot of effort. So buy the socks, they are expensive. So then they are also convinced that it must be good. The same way that placebo works better if it hurts, or if the pill is good, or if the devices look impressive. And so one thing helps the other to happen, and then you increase so your susceptibility to suggestion, and of course the creators of neurosocks can sell that quite expensively.
Yeah.
Okay, these things are harmless, right? Because so you are losing some money, but it's your fault, because so if you want to be more healthy, you should behave in a more healthy way. So it's not a few devices that will bring you there just because you wear them. So you, so the shortcuts. So this is the problem there. And so the big problem is, of course, with the more invasive technologies and the technologies recording digitally very private information from us and making it available. So this, in the case of the neurotechnologies, so we are really going very far. And so the consequences, if so, let's say this company is selling surveillance solutions, and so working together with authoritarian states, and able to enforce these technologies on people. So this is of course not desirable.
True.
And so when neuroenchantment goes that far, this is a big danger, right?
Yeah.
Yeah.
Yeah. All right. I
Yes.
really have to go. Yeah. In that case, I will stop the recording.
Right.
Thank you very much again.
Yes. Thank you too for your attention.